The amount of sugar we need to eat is 0 grams a day. Anything else is unnecessary. If it happens to be packaged in blueberries or apples, so be it. But this notion of drinking a Coke or any of these 60% of the foods in the grocery store that have added sugar for no other reason but to get you to buy them is absurd. Then when you see this happening, then you look around at what people look like these days. Everything fits in. You totally get it.
Hello, everyone. Welcome to A Whole New Level. This is Dr. Casey Means, co-founder and chief medical officer of Levels, and I could not be more excited about this conversation. It's a long time coming, and it's about the new and amazing book, Drop Acid, all about uric acid. And we are here today with Dr. David Perlmutter. So a little bit about Dr. Perlmutter. He is a board-certified neurologist, 5 times New York Times bestselling author, and I'm so fortunate to say he's also a Levels advisor. He serves on the board of directors and is a fellow of the American College of Nutrition, something that he talks about in the book that he was inspired to do after being somewhat dismayed about how little nutrition was actually taught in medical school. He serves as a member of the editorial board of the Journal of Alzheimer's Disease and has published extensively in peer-reviewed scientific journals. His books have been published in 32 languages and include some of my favorites, the #1 New York Times bestselling Grain Brain, Brain Maker, and Brainwash, amongst others. And it's really an understatement to say that these books have contributed to a tectonic cultural shift in understanding the impact of diet, microbiome, and lifestyle factors on our risk for so many of the symptoms and diseases Americans are plagued with today. And in particular, our growing epidemic of issues with brain health, everything from dementia to neurodegeneration to depression to brain fog. His most recent book that we're going to be talking about today, Drop Acid, was published in February, and it introduces really a revolutionary concept that uric acid is a key driver of metabolic dysfunction, and that by controlling uric acid, we can unlock optimal health. And this is really such a huge addition to the field. It's backed by hordes of research, but has not until now, until really this year, been a part of the mainstream metabolic health conversation. So we're going to talk all about today, how it contributes to insulin resistance and metabolic disease, and how we can get on top of it. Welcome, Dr. Perlmutter.
Oh, Casey, so good to see you again.
Yes. The last time we saw each other, we were in Miami, which was quite lovely. And hopefully we'll be able to do that again sometime soon. But so let's jump right in. So I think most people have never heard the words uric acid before. And I actually was reflecting back on it. And I don't think that I ever ordered uric acid in 5 years of residency or in clinical practice until this year when I've learned about it from you and Rick Johnson. So, can you just describe for people who probably also haven't heard of uric acid what it is, why we should care about it, and how this blood biomarker is affecting the average person?
Certainly. So, uric acid has been something people have had checked over the years, but it's only traditionally been in the context of a disease called gout. Gout is characterized by a high uric acid. Other components lead to gout. So, it's been, when you'd get your annual blood work, if your uric acid was there and if it was elevated, the doctor might say, well, you have to change your diet because if you don't, you might get gout. But the reality is that uric acid throws a much bigger net and it throws a huge metabolic net. It's deeply involved in regulating our metabolism. And in fact, taking uric acid away from just being involved in gout is something that happened in the late 1800s. Dr. Alexander Haig wrote a book describing how elevated uric acid causes high blood pressure, can be related to headaches, cognitive issues, and even depression. So, there's been a precedent for looking at uric acid through a different lens for an awful long time. But by and large, what we were taught, what you and I were taught, and people are taught in medical school is if somebody has gout and has a high uric acid, give them allopurinol and then see your next patient. It fit together really well. Gout is caused by high uric acid, give them a drug and move on. It's much more important than just, I'm not saying gout isn't an important disease, but as we look at uric acid's relationship to high blood sugar, insulin resistance, high blood pressure, the creation and storage of fat, then thinking about uric acid with all the problems that plague our modern society, Man, oh man, it becomes very, very interesting and a very powerful new tool in our metabolic toolkit. And I think the title, we don't have to even unpack an article, a study, a paper, was in 2016, collaborative study from researchers in both Japan and Turkey. The title was Uric Acid in Metabolic Syndrome, from Innocent Bystander to a Central Player. And what has happened in the past 2 decades with respect to uric acid is it has gone from simply kind of being there with obesity and diabetes and hypertension. Yeah, we noticed that those people tended to have higher uric acid. And now we recognize that it doesn't happen to be just there, it's playing a causative role. It's something that's actually leading to those problems. And in the world of blood sugar and insulin sensitivity, et cetera, to have a new tool that was previously unrecognized opens the door for us to really, gain more control, which is what we want. I mean, it's what, keeping our blood sugar under control, why that has become so central, in so many discussions these days. And now we know that uric acid's actually deeply entrenched in that whole process.
Yeah, amazing. And, I think it is so interesting. You talk a lot in the book about how Alexander Haig was writing about this almost like, what was it, 200 years ago? Was it 1820 around that he was?
No, it was in the late 1800s. Around 1888 is when he published.
Okay. I mean, it's amazing, and he was seeing this as this link between several different diseases, and I think that was so interesting to me that, like you said, we're really only thinking about it in the context of gout, even now, until now, no longer after all the work that you've published about this, and I think that certainly for me, training as an ear, nose, and throat doctor, this was not something that was on our radar because if a patient had gout, I mean, that wasn't something that we would necessarily zero in on or focus on, and so it's just so interesting to see now that this is actually something that we see elevated and mechanistically contributing to all of the conditions and diseases we often talk about in relation to glucose and metabolic dysfunction, from Alzheimer's, dementia to heart disease to diabetes. So what I would love for you to talk through a little bit is maybe some of the mechanisms of how uric acid is actually causing metabolic problems and is no longer just this biomarker that we think might be elevated, but actually is causing some of these issues.
Let me lay a little groundwork ahead of that. And first, why it matters. It matters because here in America, 88% of adults has at least one component of the metabolic syndrome. And, it's important that we talk about people and their blood pressure and their body, their BMI and their blood sugars, their insulin sensitivity or not, their blood lipids and triglycerides. Those are all interesting and important things, but it's the consequences that really, the downstream effects, the cardiovascular disease, the senile dementia of the Alzheimer's type, the strokes, etc., various forms of cancer, colon, breast, and pancreatic cancer that are related to metabolic dysfunction in many cases. So it's not just that we happen to be metabolically dysfunctional, but the biggies, the number one causes of death on planet Earth, not COVID, are the metabolic downstream issues, the chronic degenerative conditions that are beyond epidemic. This is affecting, as I mentioned, 88% of Americans right now. And we'll get to, this notion of evolutionary environmental mismatch at some point later on when we talk about uric acid. So, it's exceedingly valuable to look at it through that perspective. And again, makes us again think about how anything we can do to right that wrong, to bring people back into metabolic balance, I think is going to be very important. The other thing is that this provides now a mechanistic understanding, as we break it down, as we will now do, as to some of our unanswered questions for an awful long time, like the relationship, and we'll talk about salt later on, the relationship between salt and obesity, between salt and diabetes, between salt and hypertension. We knew there were relationships, of course we did, that's been published for decades, but now we know why. Now the dots finally got connected and we sit back, we go, oh, I get that. And one last point I want to make, and that is that I want to play upon the earlier discussion about how we looked at uric acid in the context of gout. In our medical training, we kind of were given the notion that Uric acid deals with gout, and here's the medicine. Much as we were instructed about insulin, insulin deals with blood sugar, packs it into the cell. End of story. Where did we really flesh out the role of insulin as a trophic hormone in the brain, the role of insulin in regulating protein metabolism, for example? We tend to pigeonhole things. We tend to look at testosterone as a male hormone, not recognizing how valuable it is in women. Why do men have estrogen, a female hormone? Why is there cholecystokinin receptors in the brain, for crying out now? The gallbladder hormone. Why would we have receptors in the brain? And so it is with uric acid, that it has this manifold opportunity in the body to do various things. So the the context of uric acid increasing our metabolic dysfunction is one that looks upon it initially as being something very favorable, that it's very favorable for our survival to become insulin resistant, to make and store body fat, to raise our blood pressure and perfuse our organs when we don't have water and we face dehydration. So, I think many of the viewers right now are questioning what I just said. Did Dr. Perlmutter just said that having insulin resistance and raising your blood sugar is a good thing? Yeah, I did say that making and storing body fat is a good thing for survival? You bet I said that. It's in the context of our genome and our ancestors when we didn't know when our next meal where it was coming from, or if it would even be a next meal, or we would find water to drink. So uric acid is elevated in humans to the extent that it's about 4 to 5 times higher than the uric acid in other mammals. It's also elevated in the great apes. And if I may digress for just a moment, because I think the story is fascinating, it was actually in Scientific American. The Our ancestors, our primate ancestors, about 15 million years ago, faced a time of food scarcity during what was called the Middle Miocene period, when the earth became cooler. When the earth became cooler, various tropical fruits, etc., like figs, were less abundant, and it was a survival pressure on our primate ancestors. And a small group of them had a superpower. And what was that superpower? They were able to store and make more body fat and raise their blood sugar so they could power their brains. And the signal that made their bodies do that was something called uric acid. Who knew? And what they developed over a period of 1 million years was a defect in the enzyme called uricase that would have broken down their uric acid and allowed them to excrete it. So they became basically without uricase because of genetic selection, and that gave them this superpower. They didn't become fat and obese. They became just a little bit heavier than the ones who didn't have the uricase mutation. So they survived and passed it on to Dr. Casey Means and Dr. David Perlmutter and to everybody walking the planet today. So we inherited this legacy as a survival mechanism by having elevated uric acid, such that in the late summer, early fall, when the fruit ripens and we might hunter gatherer, find some blueberries, it would be a signal to our bodies, get ready for food scarcity. Why? Winter's coming. So that small amount of fructose, which is directly metabolized into uric acid, lights up your physiology. Whoa, warning sign goes off. Make fat, store fat, raise your blood pressure, raise your blood sugar, become insulin resistant, as a wonderful, terrific survival mechanism. We needed elevated blood sugar to power our brains when we couldn't find food. Why? To avoid two things: starvation and predation, so that we would not starve. We'd be clever enough, our brain's still working, and we'd be clever enough to avoid getting eaten by some other animal that was also feeling kind of hungry. So that was our environment and our evolution, our genes, our physiology, that is the byproduct of our evolution, of our genetic expression, worked beautifully in that environment. Now, genetically, we haven't changed. We haven't had any significant metabolic changes in our genes for at least 70,000 years. But what did change were the environmental signals that we send to our bodies. And primarily, the abundance of sugar in the diet, primarily fructose. And we'll talk about the relationship to glucose a little bit later on. But when we started just pounding our bodies with ever increasing amounts of this signal, and we talk about food as the macronutrients of protein, carbohydrates, and fat, and the micronutrients of minerals and vitamins, but we tend to neglect the discussion of food as information. Food is informing us as to the environment. Fructose tells our body winter is coming, and the signaling mechanism is uric acid. Uric acid is screaming in the body, get ready. If you want to survive, we're going to help you make fat, store fat, raise blood sugar, raise blood pressure. Suddenly, we're just that signal is on 24/7 for the winter that never comes. That's the nature of our world today, is we're constantly telling our bodies prepare for food scarcity. And now, a third of American adults isn't just overweight but obese. And in the distant future, in the year 2030, that's way in the future, right? 8 years from now, that number is going to be 50% of Americans, adults, will be considered obese, basically because they're preparing for food scarcity, and they're not likely going to happen. So we call this then an evolutionary environmental mismatch. We can't really fix the evolutionary part, the gene part, nor really should we. But the relationship with the environment, we can definitely work on, because we can change the signals to our physiology and stop telling our physiology, prepare for winter, raise your blood sugar. How do we do that? We turn off the signaling pathway. That's what uric acid does. And that's why the book is written about doing the best we can to bring uric acid under control. Certainly, fructose is a major player these days. The rise in uric acid from 1920 at 3.5 to the average today at 6 milligrams per deciliter perfectly parallels our consumption of sugar, and more recently, the higher levels of fructose, because of the development of the technology to extract fructose and create high fructose corn syrup, which is very, very sweet and very inexpensive, and as such is seen in about 60% of packaged grocery store foods. So, to reduce it again, this is a mechanism in our bodies that allowed us to survive, but in a different context. And I have to say, I've been thinking about this environmental evolutionary mismatch for a long, long time. I wrote about it 50 years ago, half a century ago, gosh, in the Miami Herald. And I asked the question in that publication at the end, what about those of us living today with the outdated machinery? It's outdated machinery because we don't have time to adapt to the new environment, the new diet, the new world that we live in. And so that's the information that people need to get. We've identified the signaling pathway. Now we've got to understand uric acid. How do we measure it? How do we lower it? How do we monitor it moving forward?
That's such an amazing overview. And I was struck in the book by one of the statistics that you mentioned, which I think was that back about 100 years ago, we were eating about 15 grams of fructose per day, maybe what you might find in a small piece of fruit. And that has quadrupled since then for the average person. And again, coinciding with things that happened in the 1970s around the production of high fructose corn syrup, which was a cheaper version of sugar than sucrose. And so table sugar was replaced with high fructose corn syrup. And then we see this monumental rise in the amount of fructose. And so I think that was such an interesting concept that, it really is the dose makes the poison. The body may be able to handle and process a certain amount of fructose, especially in its whole food form. You explicitly mentioned in the book that we're not talking about whole fruit in terms of the big problem here, which is more the refined processed fructose. But when you overwhelm the body's machinery with processing this huge load of fructose, you get this big surge of this byproduct, uric acid, that's going to cause damage to the cells. And like you talk about, that in a certain context, like if it's autumn and we're a bear, and that signal may actually be useful to us because it's going to tell our body to store fat. But now it's 24 hours a day, 7 days a week, 365 days a year. So it's interesting to think of obesity as literally a flashing sign saying this body is preparing for winter that's just not coming because we're never actually going to get to the hibernation phase where we're away from food and actually using that stored fat. So, could you talk a little bit about that process of what's happening in the cell of how uric acid is actually generating fat, like what it's doing to the mitochondria? And um, I'd love for you to just touch on that. And then also maybe touch on what are the other things other than fructose that can stimulate uric acid production and feed into that pathway.
All right, let me take the second question first because I think people probably on the edge of their seats wanting to know,
Like,
gee
where
whiz,
does this come from? Yeah.
so step one is to certainly have your uric acid level measured. Go to your doctor or have that doctor send you to the laboratory or call the doctor. Say, by the way, did you do that with last year's blood work? Maybe it was already done, but you can check your uric acid level at home, much as we used to do before we had CGM. You can check it at home with a little finger stick. And here's my most recent level is, I don't know if you can see that, 4.7.
Nice.
There you go. We want to keep our uric acid levels below 5, 5.5. And the reason that's important is because, and why I mention it, because when you have a uric acid level done at the doctor's office or they send you to a laboratory, the report you're going to get or the telephone call you're going to get is, hey, don't worry, your uric acid is in the normal range. And anybody watching this podcast, they don't want to hear that. Why? Because they want to be in optimal health. They want their labs in the optimal range, number one. In the normal range, according to most laboratories, is 7 milligrams per deciliter or lower. But please understand a couple of things. That's not ideal. That's not optimal, number one. Number two, that number was derived because it relates to gout. Of course, the only thing that is important in uric acid, of course, right? So it's above 7 milligrams per deciliter where uric acid begins to precipitate in the blood, and that can lead to the formation of crystals in the joints, in the coronary arteries, and even in the prostate gland for that matter. But the cardiometabolic issues begin at 5.5. That's the level that we want to keep our uric acid at or below. And we talk about in the book times to check it, why you don't want to check it when you're fasting, why you don't want to check it after a vigorous workout, etc. If we have time, we'll get into that. But a uric acid level of 7 is dangerous. One study in Annals of Rheumatism, 2018, looked at 90,000 adults, 42,000 men, 48,000 women, followed them over an 8-year period. They found that those individuals who had a uric acid level of 7 or greater had a 16% increased risk of what we call all-cause mortality, meaning they died from anything under the sun. They had a 38% increased risk, a 38% increased risk of cardiovascular mortality. That's this gout thing, uric acid, a 38% increased risk of cardiovascular mortality, a 32% increased risk of dying from stroke. And interestingly, for every point elevation above 7, and we see it every day, there's an additional additive 8 to 13% increased risk of what's called all-cause mortality, meaning dying from anything whatsoever. So these numbers become very real. A similar study followed individuals for 12 years and showed that those individuals with the highest or above 7, they had about 155% increased risk of any form of dementia, a 55% increased risk of Alzheimer's, and about an 80% increased risk of what is called vascular dementia. There's a very powerful relationship between elevation of the uric acid and vascular problems because it affects something called nitric oxide. I'm hoping we can circle back to that. Now, let me get back to the question about the sources of uric acid. When you go online, if you have gout or want to know why you have an elevated uric acid, go on to one of the major clinics. I won't mention any of them, but the big clinic names, you go onto their website, what diet should be on. It's all about lowering your purines. That's been the big messaging in gout medicine for such a long time. Purines are the breakdown products of the DNA and the RNA that you would find in food. So foods that are very cellular, like organ meats, liver and kidney, and small fish like anchovies and mackerel. Very dense foods and even some vegetables are high in purines. When we break down those purines, ultimately we form uric acid. But two things are relevant. First, two-thirds of the purines in our bodies are generated from our own day-to-day activity, breaking down our own muscle, our own tissue, creating these purines that can become uric acid or that can be recycled to form nucleic acids. The biggest issue by far is the fructose. Who knew? And it's interesting because fructose isn't really talked about in the major clinics in terms of their websites about the low uric diets to lower uric acid. They talk about alcohol, we'll get there in a minute, and they talk about purines. But what is this reluctance to talk about sugar? And you and I, when we wrote in February of 21, wrote that op-ed in MedPage Today about sugar and American diet and the USDA recommendations, et cetera. Know and I know there's a lot going on behind the scenes that keeps people eating their sugar. And it's preposterous because we now know what it's doing. Fructose was sort of maybe on the back burner all these years. It was actually the recommended sugar for diabetics because it doesn't induce directly insulin response for its metabolism. So, until quite recently, the diabetic websites were saying eat more fructose. Caramba, you have to just wonder. I mean, the relationship between fructose consumption and metabolic issues was first described in 1970 in The Lancet, but for reasons that I would say are unclear, but you and I know very well are clear, that information just wasn't forthcoming for we medical practitioners. The third source of uric acid is the metabolism of alcohol. The metabolism of fructose and alcohol are really almost identical. But interestingly, what we know is that in large studies that use, like the NHANES study using food frequency questionnaires, we see that it matters what kind of alcohol people consume, and gender plays a role as well. As an example, men who drink wine, there's no real effect on uric acid. Women who drink wine actually are observed to have a slightly lower uric acid in comparison to women who do not. Both men and women who consume hard liquor show an association with a fairly prominent elevation of their uric acid, but the worst player by far is beer. Why? Because it contains alcohol, but it's loaded with purines. Why would beer have purines? Because it's made from yeast, and yeast is highly cellular. So brewer's yeast loads that beer up with purines, hence the uric acid level goes way up and tells the body, make a beer belly. Right? Who knew? Who could explain that in the past? I will say that Japanese researchers and public health as well, individuals have been dialed into this for quite some time. Much of the research in the book comes from the Japanese literature. And in Japan, you can buy purine-free beer. And beer doesn't have a lot of alcohol compared to spirits and wine. So there's purine-free beer because they get it. They get the fact that people drinking beer are going to have metabolic issues. So those are the exclusively where a uric acid comes from: fructose, alcohol, and purines. Now, let me digress because it's important. And that is that the question of fruit consumption always comes up. If fructose is where the word fruit sugar is where fructose comes from, should I eat fruit? And the answer is yes, in moderation. Why? And you alluded to it before. Your typical apple might have 5 grams of fructose in it, so we can live with that. 5 grams of fructose when you consume it, you don't drink an apple, so it's going to take you a little time to consume it. That will be metabolized by the small intestine and pretty much dealt with at that level and won't make its way to the liver where all the problems really begin. The other thing that is that fruit has fiber, which slows fructose release in the body. Fruit contains bioflavonoids like quercetin that target one of the important enzymes in making uric acid, which is called xanthine oxidase. Happens to be where the gout drugs work, like allopurinol and febuxostat. They target that very same enzyme, like quercetin and luteolin. And finally, Fruit contains vitamin C, and vitamin C aids in uric acid excretion. Can you go overboard? Yes. An apple a day keeps the doctor away. 5 apples a day, the doctor you will pay. But I do think it's valuable to note that there are high purine vegetables like the cruciferous vegetables, and their consumption is associated with a lower uric acid. So the same mechanisms are involved. So we get away with eating a lot of those fruits, not a lot of, but eating those fruits and vegetables, and I think you can eat the organ meat if you choose in moderation and have the anchovies and sardines and scallops, though they have high levels of purines. The big issue is the fructose, like in a glass of apple juice or orange juice. And, I love looking at the carton in the health food store. It says all natural orange juice. It has, what, 36 grams of sugar in a glass? And there's nothing natural about that. Our ancestors didn't find cartons of orange juice on trees. Our bodies are not set up to deal with that bombardment of fructose. Why? Because when it happens, you're telling your body winter's coming, and you are signaling it through the production of uric acid that lights up fat production, which is your second question. How does it do so? The main thing it does is acting in the mitochondria does a couple of things through its inhibition of an enzyme. If your listeners want to know this, if it's going to
Oh, I
be on the
think so.
quiz,
Yeah.
it's called cis-aconitase. So cis-aconitase is the enzyme that's inhibited, one of the enzymes. NADP oxidase is another, but nonetheless, when inhibited by uric acid, both compromise our ability to burn fat as a survival mechanism and increase our production of fat as a survival mechanism. And the third thing is there's a general downregulation of mitochondrial function as a way of conserving energy. So, this starts to ring a bell for many people that there's a pathway, a physiological pathway that we like to stimulate because it tells the body, don't make fat, burn fat, turn up energy utilization, keep the blood sugar low. And that's, we talk about something called AMP kinase or AMPK. That's what we're doing our best day in and day out to stimulate because it's basically telling your body the hunting is good. It means you're in great shape. We don't need to pack it away. Everything is good. We're going to use our fat for energy. Who wouldn't want that? We're going to keep the blood sugar where it needs to be. We don't need to we don't need to generate new blood sugar, gluconeogenesis from the liver because we're doing just fine. So we want to do whatever we can to keep AMP kinase lit up, doing its job. And that means how do you stimulate your AMP kinase? Exercise is one of the most powerful things you can do for your health. How so? It stimulates AMP kinase. Quercetin. Now, that's the second time I've mentioned it. First, because it inhibits the enzyme that makes uric acid called xanthine oxidase. And second, it stimulates AMP kinase. Who wouldn't want that? Third, you could take a pharmaceutical called metformin as well. Uh, that's not what we're necessarily about. If a person needs metformin for their diabetes to inhibit their production of sugar in their body, that's between them and their doctor. But I'm simply describing this mechanism. Now, the evil twin of AMP kinase is AMP deaminase. Almost the same, but does exactly the opposite. It's the evil twin. It says winter's coming. It says ratchet down the metabolism, power the brain with glucose, make more fat, and store more fat. And it's this AMP deaminase that's really active. You alluded to it earlier when a bear is getting ready to hibernate and needs to make as much fat as he or she possibly can and keep that fat locked up. How does the bear get ready to hibernate in the winter? It eats pounds and pounds of berries every day. And what does that do? Fructose, uric acid, shuts down AMP kinase, lights up its evil twin, AMP deaminase. Uric acid directly works against us by taking AMP kinase offline. So, as your viewers have heard about AMP kinase before, and all the things that we try to do to stay healthy and keep AMP kinase doing its job, the worst thing you can do is have a high uric acid, because that's totally working against you. It's knocking down AMP kinase. You can't help but make more body fat, raise your blood sugar, become insulin resistant, raise your blood pressure, I might add, as a survival mechanism against dehydration, which take us to our next topic. And it's a losing battle. So for people who not making the grade, they're monitoring their blood sugars, they're trying to be low carb as possible, doing their best to exercise. Something's missing. I don't know what it is. There's got to be a missing link here. I don't know what it is. Got to check your uric acid, because that could be, the monkey wrench in the whole system that's keeping you in metabolic mayhem.
Amazing. Such an incredible description of all that, Dr. Perlmutter. And I want to drill in like a little bit more on insulin resistance and the development of insulin resistance from uric acid, because our listeners, of course, at Levels really care about insulin resistance. And I think one of the things that has kind of been drilled into everyone's mind is that repeated glucose spikes cause repeated insulin spikes, and then the cell becomes numb to insulin and we develop insulin resistance, and then of course we have to produce more insulin to drive glucose into the cell. And that's kind of one prototypical pathway that we've heard a lot for development of insulin resistance. But what uric acid does, and why I think it's one of the most interesting things I've learned about in the past 10 years, is that it's like a whole nother way of looking at how insulin resistance develops in concert with that, which is, that basically what you just talked about, we're storing fat, including in the liver, and then that fatty liver essentially creates an issue where the pancreas is needing to produce more insulin. It's becoming insulin resistant. The fat in the liver actually is blocking that signal, and that's a problem. But there's other mechanisms involved too, like inflammation from uric acid generating insulin resistance. And there's a lot going on. So I think the question I have for you is, one, can you describe a little bit the relationship between uric acid and the development of insulin resistance? Maybe speak to, given that most people are more familiar with that former framework that I talked about, how those two are related, um, and yeah, and I think just like paint this expanded picture of insulin resistance that we're now understanding in the context of uric acid, that's somewhat separate but interrelated than just the glucose stimulation.
Sure. I will say, Dr. Means, it's, for those weenies of us who really enjoy this stuff, it's an incredible story, because, frankly, our job is to connect dots, is to really try to figure it out. And you had just asked a question. Well, we know that, the cell gets kind of tired of answering the door when insulin's knocking, and that's sort of what happens. And then the insulin doesn't do its job. The pancreas has to make more and more insulin to get through and get the glucose into the cell. And it's an interesting mechanism. It works for understanding, but now we have an issue that when we look at becoming insulin resistant as a survival mechanism, it is. How does that work vis-a-vis the whole uric acid fructose relationship? And fructose is involved. But let me first focus on a mechanism, and there are several, but let's first focus on a really kind of exciting mechanism, and that is uric acid directly inhibits nitric oxide functionality, nitric oxide generation within the blood supply, within the actual arteries themselves and the vasculature. Now, what does nitric oxide do, and why would its inhibition be problematic for us? Nitric oxide, we know, is important to allow arteries and smaller vessels to relax. Why is that important? Because then they can carry blood to the organs. When the blood vessels are constricted, we run the risk of not having enough blood supply to our organs. And I quoted to you a statistic earlier that showed about a 32 to 33% increased risk of stroke, death from stroke, in individuals with high uric acid. Now it starts to make sense. And Alzheimer's, which is certainly a vascular component to that. So we understand that, and that's certainly very important. Uh, and yet we tend to overlook another important role of nitric oxide, and that's for insulin functionality. So for insulin to get out of the artery and to get and then to allow to facilitate how insulin, the entry of glucose into the cell requires the functionality of nitric oxide. This becomes very, very important when we look at some of the clinical relationships to dysregulated nitric oxide and how uric acid then might manifest as clinical disease. And let me break that down just a little bit. So there are several drugs that people have heard of that are involved in increasing nitric oxide and as such allowing better blood supply. What is erectile dysfunction? Erectile dysfunction is lack of blood supply that causes an individual to lose the ability to maintain or achieve or maintain an erection. So these drugs were developed to enhance nitric oxide functionality to allow erectile function. And that's an important role then as we see of nitric oxide. So an interesting study was published earlier this year looking at several million individuals and found that those men, primarily, though women do take some of these drugs as well, those men who took these drugs like Viagra had a 70% reduced risk of developing Alzheimer's disease. There is a strong vascular component to Alzheimer's disease, but make no mistake about it, the role of insulin in the brain is fundamental. The elevation of blood sugar in the brain that is not being used is critically important. We'll get to that in just a minute. As a sneak preview, it leads to elevated fructose, which leads to elevated brain uric acid. My point is that we now have this really new, and for those of us who enjoy this stuff, exciting and valuable tool in our understanding, and that is this relationship between elevation of uric acid and its compromise of the functionality of nitric oxide, which has two downstream, very significant effects. Number one, a vascular effect. Number two, an insulin resistance effect as well. So it opens up the door for us to target uric acid as a way of improving blood supply. It's noted that men who have elevated uric acid have about a 38% increased risk of erectile dysfunction. And that's a pretty good marker of vascular functional defect. Men with erectile dysfunction have a dramatically increased risk of cardiovascular death, for that matter. So this is really starting to tie up some loose ends. Now, let me segue to another part of this whole mechanistic understanding of the role of uric acid and tie it back to where we just were. First, I'll summarize. Uric acid inhibits nitric oxide, blood vessels can't relax, insulin doesn't work as well. And that's a survival mechanism. That's one of the tricks of uric acid that allowed us to survive. Because when we slow blood supply through the body by keeping those blood vessels tight, we can get by when we're deeply dehydrated. There's a and that's where we'll go next. How does this whole pathway relate to our survival during times of water scarcity? I mean, you can understand the food scarcity, make more body fat as a resource, a reservoir of calories, you'll survive. But there's a powerful mechanism that allows this pathway to allow our survival during times of water scarcity. How incredible. And it gets to another pathway that will be on the quiz. It's called the polyol pathway. And the polyol pathway, write it down, it's going to be question 34. The polyol pathway is how our bodies endogenously create fructose. Can you imagine? You don't eat any fructose whatsoever. You're reading labels, you're eating nothing, and yet there's fructose being produced in your body. Now, what triggers your body to activate the enzymes involved in the creation of fructose de novo from the glucose circling around in your body? And it's various types of stresses. One primarily is when the body thinks that it's dehydrated. And when you can't find water, you're a hunter gatherer, you can't find any water. What is, somebody goes to the hospital with dehydration, you look at their blood work, their sodium is elevated, right? You have a high sodium. And what does that high sodium do? Well, vasopressin is activated, et cetera, but it stimulates an enzyme called aldose reductase. And aldose reductase is fundamental in this polyol pathway to convert your blood sugar into fructose, telling your body to make and store fat because you're dehydrated. Well, why in the world would you want to make fat? So we turn to our friend, the camel. The camel has this huge hump on his back or her back, walks across the desert, doesn't get dehydrated, doesn't drink any water, and yet manages to survive. Why? What's the superpower here? It's the hump. What's in the hump? Fat, up to 80 pounds pure fat. When we burn fat, we produce carbon dioxide and water, metabolic water. So making and storing body fat has been a powerful survival mechanism against dehydration. Who knew? It's why the hummingbird, when it's going to make these epic voyages or whatever you call it, thousands of miles, stores up to 40% of its body weight is fat. A fat hummingbird, who knew? But if you want hummingbirds in your backyard, you put out sugar water, right? And they convert that into body fat. They have a reservoir, yes, for calories, but to make metabolic water as well. Now, you're dehydrated, your sodium is up. You stimulate aldose reductase, you convert glucose into fructose. Alarm signals, uric acid, make fat, metabolic water. That's kind of interesting. The problem is that you can raise your serum sodium just by eating a bag of chips. So you park yourself in front of the playoffs or the Final Four, whatever it is, and sit there munching chips. Not only the carbohydrates that are, the processed carbs that you're going to raise your blood sugar, which also activate this pathway, but it's the salt. Your serum sodium goes up, and the next thing you know, you're getting fat. And why are you getting fat? Because you've stimulated the survival pathway. So again, I alluded to that earlier, that we've known that there's a relationship between eating a lot of salt and getting fat, between eating a lot of salt and becoming insulin resistant, between eating a lot of salt and having raised blood pressure. And now we know why. Uric acid is sending the signal and does a couple of things that are so incredibly important here. Exciting is the fact that when fructose, the first step in the metabolism of fructose is utilizes an enzyme called fructokinase. So fructokinase uses energy, ATP, unlike glucose metabolism, uses ATP and creates ultimately ADP and then AMP, AMP adenosine, which becomes uric acid monophosphate. It's that adenosine that has to be dealt with by AMP, adenosine monophosphate kinase, or ADP, AMPD, AMP deaminase. That's where that adenosine has to go, either recycled back up to make more ATP, or it's broken down further or converted into ammonia. But that said, uric acid stimulates fructokinase. It stimulates the metabolism of the very thing that created it in the first place. So normally in the body, we have feedback inhibition, where at the end of a metabolic pathway, there's a signal to shut this off. Not in this case. We don't want to inhibit fructose metabolism. We want to keep it going, because if it's not going to keep going, we'll die as when we're starving or we're dehydrated. It's so powerful. It's so cool to keep us alive that whole pathway is lit up. And it turns out, where the story gets really interesting, that this fructokinase enzyme is really very, very important, because in the laboratory animal, we talk about what happens when you eat a lot of fructose. You develop something called non-alcoholic fatty liver disease. And by its name, it's developing, as you talked about earlier, fat in the liver and then in the body, unrelated to your consumption of alcohol, right? We know that alcohol consumption is going to make you have a fatty liver and ultimately cirrhosis and who knows what else, liver cancer, etc. But this is not alcohol related. But in the laboratory animal, if you block fructokinase, if you block the metabolism of fructose into uric acid, you can give laboratory animals alcohol and they don't get alcoholic fatty liver disease. It's the same thing. And the reason is because alcohol similarly stimulates the production of fructose in the body from glucose. So, we delineate between alcoholic fatty liver disease and non alcoholic fatty liver disease. They're the same thing. They're mediated by this pathway of fructose becoming ultimately uric acid and stimulating this lipogenesis, this production of fat in the liver. So the notion of inhibition of fructokinase as a treatment for non-alcoholic fatty liver disease and even alcoholic liver disease, fatty liver disease, is now being vigorously studied. There is research being done at pharmaceutical companies to inhibit fructokinase as a way of helping people stop this whole signaling pathway, keep their blood sugars in check, their blood pressures in check, and stop this crazy production of body fat.
Oh my gosh, I could listen to you talk all day. Dr. Perlmutter, that was amazing. I mean, it's literally like on the edge of my seat because it's like such awe for the body. I mean, here we have this molecule, and like you described back in this conversation about blood pressure, it has dual effects. It has so many effects, but one is to literally change nitric oxide functionality, constrict blood vessels, and then on the flip side, makes you store fat so that you can have metabolic water, both of which are going to help you in times of dehydration. Like it's really mind blowing that it's doing all
It's
of that.
so interconnected. As the insulin resistant person develops higher and higher insulin levels, as is the case, insulin inhibits uric acid excretion and fans the flames, and keeps this whole process going. The other important factor that stimulates the polyol pathway to make fructose in the body, we talked about alcohol, we talked about elevation of serum sodium as a signal that we're dehydrated, is glucose.
So this was going to be my next question, actually, that I do want to set up because this is something that I think is going to be mind blowing to everyone listening and everyone who reads your book. Is that again we've really focused on this paradigm of glucose causes insulin resistance because glucose stimulates insulin repeatedly, which then causes the cell to become quote unquote numb to it, and then we get insulin resistant. But this is bringing in a whole nother lens, which is actually that like you said, there's multiple things that can activate the polyol pathway, but one of them is glucose. And it actually could be the glucose to fructose conversion and then the subsequent uric acid and lipogenesis in the liver that's actually causing insulin resistance and then feeding into more glucose instability. So, what I'd love for you to do is maybe talk about that a little bit and maybe give an assessment, because this is a question I actually still have of like, how do these what's the weight of these kind of relatively in the body in terms of what glucose is doing on its own and then what glucose is doing by nature of it being converted to fructose at high levels? Because we also know glucose has lots of sort of its own effects on the body as well, like inflammation and oxidative stress and things like that, which can feed into these processes. But like
Glycation.
glycation, how do you see that these two different mechanisms kind of relatively contributing to the problem of insulin resistance?
I think importantly, I mean, one of the factors involved here that really resonates is the fact that it's a feed forward, no pun intended. It's a feed forward mechanism that works, that worked for our ancestors to keep them alive, kept regenerating these signaling molecules, to keep the alarm sounded, and that's what's going on today. I think that to recognize that every action of glucose is not just either as an energy source or to be packed away as glycogen or spilled in the urine, as the case may be. This is a new sidelight. I think it's very, very important. I think the glucose to fructose conversion and then the activation of these pathways, again, that self-stimulate, I think is really very, very important. And we know that based upon interventional trials that can inhibit this pathway at multiple places, like inhibiting fructokinase, like inhibiting uric acid production by giving people allopurinol in research setting and seeing improvement in their metabolic parameters quickly. So these studies involve humans, first animals, then humans, where they'd give them 180, 200 grams of fructose in a day. Within a couple of weeks, they would have many metabolic issues, which would not happen when these individuals received that level of fructose, but had its metabolism as it relates to uric acid production blocked by simply giving them a gout pill called allopurinol. I want to mention parenthetically that quercetin as a nutritional supplement uh, works almost as effectively as allopurinol. I mentioned earlier it targets the same enzyme called xanthine oxidase. One study in 22 young men with mild elevation of their uric acid over 8 weeks, giving them 500 milligrams a day of quercetin, dropped their uric acid by about 8% just in 8 weeks. So you're targeting that enzyme involved in the manufacturing of uric acid. And the point is, you break the cycle. And there are many opportunities to break the cycle, along the way. As I mentioned earlier, the inhibition of fructose metabolism by inhibiting fructokinase is being studied aggressively, and I think we're going to see medications that will do that. But you can inhibit your xanthine oxidase right now. You can do it by taking quercetin 500 milligrams a day, or taking luteolin 100 milligrams a day. Aid yourself in the excretion of uric acid by taking 500 milligrams a day of vitamin C. And certainly on the front end, limiting your consumption of the fructose that we talked about, and limiting the production of fructose by the activation of this polyol pathway. The relative weights I think you were getting at, I think has yet to be determined, because we're just beginning to see the interventional trials. And I think it's going to be difficult to determine that. What we are going to soon see is measurement of the actual enzymes involved in the polyol pathway in clinical practice. Looking at this aldose reductase, that's the rate limiting enzyme that is involved in the conversion of glucose into fructose. If we can see what is your baseline level of aldose reductase, in terms of making fructose in your body, do something, something interesting, and then see if that affected the aldose reductase. Man, oh man, that's going to be a really exciting time, because then we're cutting down the fructose, which is very difficult to measure, production. And I truly believe you'll see that reflected in the uric acid level, and we'll see wonderful clinical benefits from that, I predict, with respect to blood pressure, blood sugar, insulin sensitivity, HOMA testing, as well as lipogenesis. So that's where we are right now. And over the next few years, this is going to absolutely explode. Even since the book came out in February 15th of 2022, there's been such an increased interest amongst, people like yourself and people who are deeply involved in understanding human metabolism. So I think, it's exciting. It's really exciting. The biochemistry is so meaningful in the context of our ancestors, that this is a conserved mechanism in each and every one of us today that worked to keep us from dying. I mean, it's if you look at it through that lens, then you can begin to appreciate that we live in a time of this genetic environmental mismatch. We're not going to mess with the genetic just yet. We don't have that technology, though who knows what's the future's like. But we sure as heck know how to how to influence these pathways in terms of modulating our environment, modulating our food and our activity, getting back to doing what we can to activate AMP kinase. That's been a topic I'm sure you've talked about before on the podcast. So many people talk about it, but what's the big thumb on your head keeping you from getting that AMP kinase lit up? That is elevation of the uric acid.
Amazing. I think, yeah, what you just said about the research, I think I really do feel like it's probably going to explode after the publication of your book and Rick Johnson's book, that also talks about uric acid, because there's going to be this amazing. This is what I think is so amazing about books like the books that you've written, is that they educate, the not only the lay population but physicians as well, and researchers, to spark this whole new interest. And it's just such a gift that you, as such a preeminent medical communicator, can take all this science, communicate it in a way that people care about and can understand, and then how that's going to feed into the next 10, 15 years of what PhD students are interested in researching about. Like, it's an incredible cycle of medical communication and synthesis that I just think is so that you do so amazingly.
It's a hashtag OMG, there's no question. I mean,
Yes.
for anyone who's puzzled over these things, I know it happens, but actually, how and why? Well, how does it happen? Yeah, and why? Why is answered in the context of our ancestors. Why means why do we have this pathway? If it's so bad, why would it have persisted? As an example, we know that it amplifies inflammation. That's a good thing when are injured and have the possibility of an infection, for example. Why do we still have the APOE4 allele in our population if it's so dramatically associated with Alzheimer's disease? Why would it have persisted? Great question. When you look at underdeveloped cultures that live in equatorial areas, those who carry the APOE4 allele in the presence of their vast parasitic infections have a much lower risk than non carriers in terms of Alzheimer's. That's our hunter gatherer ancestry. And yet we confront that with our very hygienic environment today. We get this hygiene hypothesis that says our incredible hygiene might be, having some significant counter effects in terms of keeping us healthy.
Definitely. I think one of the reasons thinking about the evolutionary aspect of this is so interesting because it makes us realize that, like, really what we're dealing with here, all the issues we're dealing with are the result of chemical pathways kind of being hijacked by our modern lifestyle. So if we can understand that and then just work to take the accelerator off a lot of these pathways, it makes more sense why we might have to make some of these hard lifestyle decisions. I think when you don't necessarily understand these mechanisms or these pathways that you've so beautifully described, it can feel a little bit more like, why should I make this really difficult lifestyle choice? But in the context of this, it's clear. It's because we want to give different information to our bodies to get off this evolutionary, environmental mismatch. Quick question for you, because this is
Sure.
something I was wondering. And I couldn't find anything in the research. Do we have a sense of at what glucose level the polyol pathway is activated to convert glucose to fructose?
My sense is that it's mild elevation. I mean, uh, and the reason I say that is because I think it's pretty clear. One would anticipate that the general glucose level and area under the curve and excursions, all the important parameters, might would likely have been a pretty low in our Paleolithic ancestors, based upon their lifestyle activity and certainly based upon their diets. Now, again, all bets are off at certain times of the year when they might have had some access to fructose, found some honey or berries. But I think that these days typical blood sugar measurements that we see are absolutely activating that pathway and creating endogenous fructose, and therefore explains why we're seeing such incredible numbers as it relates to the number of people with elevated uric acid, which it's not necessarily the case in other countries. So, you know, why so? It's yeah, the purine's an interesting story, but look, it's mostly the sugar. Thank you very much. It's the reason you wrote and I wrote that op-ed. We've got to get our sugar consumption down. Sugar be bad. Humans don't need to eat. The amount of sugar we need to eat is 0 grams a day. Anything else is unnecessary. If it happens to be packaged in blueberries or apples, so be it. But this notion of drinking a Coke or any of these 60% of the foods in the grocery store that have added sugar for no other reason but to get you to buy them is absurd. Then when you see this happening, then you look around at what people look like these days. We talked the statistics earlier. Everything fits in. You totally get it. And our mission is then to interrupt this, is to identify it, interrupt the pathway, and give people the tools to rein in their metabolic health. And job one is to know your uric acid level. If you don't want to stick your finger with and get a drop of blood on your home uric acid monitor, then by all means go to your healthcare provider and say, I'd like to know my uric acid level. What will happen then is that you'll probably be asked, well, why on earth would you want to know that? You don't have gout. And I would keep in mind that people tend to be down on what they're not up on. So again, mainstream medicine is going to say, you don't need to know your uric acid, be a good little patient and go home because you don't have gout. And I know you might have heard it someplace, but we don't really need to test it. So that's when you have to be, you have to be your own advocate, and maybe get the home monitor, or see somebody who will check your uric acid level. I think many integrative healthcare practitioners are dialed in on this now, so it shouldn't be that difficult.
Definitely, and then also people can just bring your book to their doctor and share that with them.
Oh gosh, I can tell you stories about grain brain. My gosh, when it got thrown in the garbage by
Oh.
doctors because it was based on 500 peer-reviewed studies. But back then, that was 2013. I was saying that maybe we shouldn't be eating, oddly enough, as much sugar as we are processed carbohydrates, because there's this relationship between fasting blood sugar, as published in the New England Journal of Medicine, and risk for developing Alzheimer's disease. Not to mention gluten in some people leading to neurological issues, as was described, in early 2000 teens by Dr. Marius Hadjivassiliou at Oxford, where actually I'll be in a couple of weeks,
Ooh.
talking about various neurological issues that he had found great success in improving with a gluten-free diet in non-celiac patients. Who knew? Um, I was on the CBS This Morning show a couple of years back, and they said, we asked so and so doctor about your book, and he said it was nonsense. And yeah, he did say it was nonsense at the time it came out. Now he's using it at Yale in the Alzheimer's prevention program, using Grain Brain as one of the fundamental texts. So, that's great. People admit that, maybe there is some reality out there. And who knows what you and I talk about 5 years from now? It may be completely different. But, uh, if we can get so granular as to be able to review these mechanisms in the textbook of biochemistry, it's right there for you. And who would think at my age I'm buying the latest version of Leninger textbook of bio no Stryer textbook of biochemistry, which has been updated 2 years ago. It's great to learn this stuff. That's the book I have by my bedside right now. How boring am I? But anyway, because you want to understand this stuff because it's got direct clinical application.
It's amazing, and I think the whole story of how you came to this, which you mentioned in the book, is you were listening to a Peter Attia episode, and then you just got it started to connect some dots for you, and then you went down the rabbit hole, and I think it's just such a beautiful example of, like, how we can never stop being learners, and how and then this journey it's fun. It's been fun for you, now it's fun for me, now I hope it's fun for the people listening, and it's like, it's this feed forward to go back to feed forward of just, like, this joy in learning and understanding that I think is so exciting and cool.
And it's
And
okay to be wrong.
yeah.
People tend to be critical about that you said one thing and now you're saying something else. Because, I think back 25 years ago, I was telling my patients, best bet, low fat diet, right?
Mhm.
Because that's what the literature that was influenced, we now know by whom, but was telling us that's what we should be recommending. And that's what I did. I mean, there were all the studies, the various heart studies, etc. The lower the fat, the better. The Dean Ornish program. And so I changed that messaging for obvious reasons. Now, began saying to people that it's not just low fat, but let's welcome fat back to the table, but be careful about what types of fat we are consuming. The real villain here are the refined carbohydrates and the sugars. And it took an awful long time for that message to gain traction, though it still hasn't fully gained traction, which is why, again, we wrote the open letter to President Biden. You and I did that.
Yep. Yep. And the Dean Ornish diet, that's an interesting one because, like, it does that one to me seems like the best possible version of that diet in the sense that it's low fat, but it's also whole foods based. And so it's so low-ish sugar. But I think the general low fat, like, message that we were getting in the 90s was like, literally fill those calories that you're replacing with the fat from with carbohydrates of any kind. It's better than the fat. And that, of course, was the most disastrous, like, thing that could have happened to the American
We've
population.
been eating fat for couple 100,000 years as a wonderful resource, a wonderful food. But I think, the bastardization of dietary fats now is very, very real and very threatening. So
Yeah. Okay, 2 questions I just wanna wrap up with you, the quick ones. So one is back to salt. I just wanna get just sort of a tactical thing here. So I think something you brought up really interestingly about dehydration being one of these mechanisms that can actually make us generate uric acid and even maybe contribute to weight gain. So the body sees dehydration both with low if we don't have access to water, but also it sounds like if the salt concentration is high in the body because of stuff you're eating. And so we want to just to nail this down for people, like it sounds like staying hydrated and avoiding excess salt.
absolutely. What the research shows is, you can give two groups the same amount of salt, but if you give one group uh, water, drink water after they do their salt consumption, then this doesn't happen. They don't activate the polyol pathway as readily and don't go down that rabbit hole. And certainly for people who are deeply into keto or exercising aggressively, there's a place for salt, magnesium, potassium repletion in the context of making sure you're drinking enough water, which is, really a great recommendation. I don't know if it's 8 glasses a day that your mother told you or whatever it was, but most people are just not drinking enough fresh water. And it's really very important for the simple reason, there are many, but the simple reason of trying to dilute down the sodium that is so pervasive in our foods today.
I love the concept of we're literally diluting our blood so that we don't activate the polyol pathway to convert glucose to fructose and make fat. It's like that to me, learning that feels like one of the most motivating things I've ever heard about drinking water. And so I love that. Um, so that was just wanted to mention that, and also just that stat from your book that there was a study done that showed that a high salt diet for just 5 days in humans can lead to insulin resistance, which was just like
And
mind
a
blowing.
very, very low salt diet actually leads to mitochondrial biogenesis, the creation of
Mm.
mitochondria. Who's not going to want that?
I did not know that. That's fascinating. Okay. But too low is also not good, of course, because like you can
That's
get into a
true. So, I mean,
pathologic.
there are various products out there. One of them that I use on occasion is called Element, and that does contain a little bit of salt in the context of magnesium and potassium. In with water is reasonable. If you're in ketosis or you're exercising aggressively, you should do that. You should have those electrolytes on board. That doesn't mean drink Gatorade or other sports drinks that are loaded with sugar and much higher levels of sodium. I mean, that was an attempt to replete minerals in high-end athletes, but driving it in with fructose in mortal men like me is not necessarily what you want to be doing.
It also feels like we don't wanna pair our salt and our sugar because if you're gonna be activating potentially this pathway as well, you don't wanna have a ton of glucose and fructose on board to sort of compound all of that going on, and
And yet, what is a bag of chips or pretzels? It's not
carbs and
sugar, but
salt.
it's a refined carbohydrate, may as well be. And it's salted. So you've got the raw material to make fructose and you're turning on the pathway with the salt and off you go. And your weight goes up and you wonder why.
The funny thing, I use Element and, which I really like, it's sugar-free and it's, mostly they talk about the fact that this is especially useful on, like, a ketogenic diet or a low-carb diet, and so it's sort of it's the context, and it also the funny thing about it, they're very concentrated packets. Each one actually only has 1 gram of sodium, and I end up drinking it in 3 1-liter jars of water over the course of the day. So it actually, I think, gets me to drink way more water than I would
As
normally.
you should. And now you know why you're doing that. You're for all the right reasons.
Last question that I'll wrap up with is about leptin, because I think one of the most interesting things about this whole story is how uric acid actually drives us to be hungrier, which feeds back into the concept you talked about of like if you're a bear and you get the fructose signal and start generating uric acid, you actually want that bear to become like hyper motivated to eat as many berries as possible before winter comes. So this is actually super relevant, I think, to us now because is that basically what's happening to the human brain is that we're stimulating hunger. So can you talk a little bit about the effect on drive for hunger and also what it's doing to our like satiety signals?
It's blunting our satiety signals as a survival mechanism. It's leading to what we call hyperphagia, and so that we'll eat more and we will survive. But beyond that, there are some behavioral ideas that are changed as well. That with the in the presence of this elevation of the endogenous fructose, that we become more likely to be risk takers. Why? Because it's the risk takers who are going to be more likely to expose themselves to environments where they might find food, whereas the more conservative individual not taking the risk might not find food and might not survive. So this idea of not learning as much from your environment is, sort of an explanation as to why there's this relationship between high levels of uric acid and risk for Alzheimer's disease. So again, as a survival mechanism, in the context of today, there's a powerful survival advantage to being not fixated on certain things and just taking risk and risky behavior. Sure, there's a risk of injury, but that's going to be the individual who may ultimately find the water or find the food.
It's so fascinating. It's so fascinating to think how we're like literally being controlled like little puppets by some of these biomarkers. And for those of us who have dealt with like cravings or just, kind of feeling like insatiable hunger, things like that, I think this is also so empowering because you can think, I can actually change my behavior by potentially taking the gas off some of these pathways. So
Can you imagine you are influencing how you see the
it's
world
crazy.
based upon your dietary choices. So we know that we have two very important decision making areas in the brain, if you will. And this is going to be somewhat simplified. We have a primitive, impulsive, non forward thinking, I want it now area called the amygdala. And we have the more advanced prefrontal cortex that looks at a lot of information, comes up with a really good decision, that takes into account how my decision is going to affect other people, how it's going to affect me, what the impact of this decision may be a year from now, whatever. So that's basically the adult in the room, right? Because that prefrontal cortex exercises top down control over the more impulsive 5-year old, the amygdala. That pathway is fundamental. When we sever that pathway, we disconnect from the top down control. We take the adult out of the room. In brainwash, we call that the disconnection syndrome. And it turns out that inflammation severs the pathway. So when we become inflamed, as is what happens when uric acid level goes up, that's what gout is all about. We lock ourselves into a very simplistic decision maker that will further eat the crappy food and further choose to spend time not exercising but watching TV, and it creates really a vicious cycle. So we need to bring the adult back in the room. So we need to bring that uric acid level down, reduce inflammation, and everybody knows the right thing to do, but we don't always do the right thing because sometimes we give in and the adult leaves briefly and we take full advantage of it. So, it's all about making better decisions that look at the long term, not just right now. Would I eat a huge chunk of chocolate cake right now if there was no implication for it? Yeah, I would. Who wouldn't? But my prefrontal cortex says, you know what? You want to get fat and raise your blood sugar, and your continuous glucose monitor is going to probably fry, and Casey's going to see the results and call you, whatever. So we don't do that. So that's because we keep the adult in the room as much as possible.